Meshing is used to break up a complex problem into discrete and solvable elements and achieve a result that is fast, stable, and accurate. There are different element shapes that can be used to capture the geometry and areas of importance. We will be using tet elements around the fairing to capture the shape. Wedge elements are created to capture the boundary layer, with pyramids automatically being created when needed, and then hex elements around the domain. Fluent uses an iterative solver, calculating to conserve mass, momentum, and energy in each cell. A coarse mesh may be quick, but unable to capture the flow characteristics. A fine mesh may be accurate, but encompass high computational resources. Determining appropriate mesh size takes time, and we'll go over different techniques and principles. For now, we will auto-generate a mesh and set up Fluent and Post. After the model has been set up, we can go back and improve the mesh to obtain an accurate result. Now that we're in the meshing module, let's first create some name selections to inform Fluent about the different boundary conditions. The name selections we need to create are for the inlet, the outlet, the sky, the ground, symmetry 1, symmetry 2, and fairing. Make sure to highlight all relevant faces when creating the name selections. The shortcut extend to limits or F2 can be used, and N to create the name selection. Let's incorporate a swept method. It'll allow us to control what elements are in the domain, the number of elements through the domain, and how the mesh is created. Now, as you can see, when it generates the mesh, it generates from outside in, which we don't want. So we're going to create a worksheet and start to record our mesh. So we're going to right click on the fairing first and generate that mesh. We can then generate the adjacent domains. Now what this meshing technique is doing is creating a mesh from the inside and working outwards.